Okay, this is Module 12, Game Theory in Blockchain, and this is the lecture 2 is about a remote purchase, and we're going to see this scenario. So the idea here, we're going to talk about remote purchases and how to apply a little bit the game theory that we see, but before doing so, we're going to finish a little bit some aspects of the game theory and the normal form that we didn't finish in the previous lesson. So before going to remote purchases, let's see a little bit to finish. Let's see the relationship between the game tree and the normal form. As we see, here we have two game trees, and they're different, okay? Because in the game tree in the left, we have one player, player 1, and player 1 can play A or B, and then player 2, knowing this information, can play C or D. Okay, if I take a look at the strategic representation of this game, of the game on the left, then I would see that this is this table here. Okay, in this case, my strategies are formed only of one element. My strategy is just the strategy of player 1 is only. There are only two strategies, play A or play B, and the strategy of player 2 is just play C or play D. Okay, they are single. There are only one decision node or one information set for each player. Okay, and on the right we see another game which is a different game, because player 1 here can play A and B, but in this case player 2 is not seeing what player 1 played. Okay, so player 2, now these 2 points on the tree, from this is an information set here, so I don't know, player 2 doesn't know which was the action by player 1. And from this information set, we can play again C or D or C or D. Okay, and maybe we can draw the same outcomes and everything is the same. Okay, so if we represent this game in a strategic form, then we end in the same table. Okay, because the strategic form is like seeing the game played. This strategic form is like seeing the game played in one shot by both players, and played in one shot, these two games are exactly the same. Okay, because we lose the idea of sequential moves, or you didn't know what the other played. So the strategic form is compressing a little bit of information, and different game trees, as you see here, go to the same strategic representation, because in the strategic representation we are not describing or we don't have information about if player, for example, if player 2 take the decision with or without knowing what player 1 did. Okay, this information is not present in the strategic representation or this table here. Okay, so yeah, this is what I wanted to say. And finally, before going to the scenario of the remote purchase, let's see how to build, how to create the strategic form for 3 players. Because up to now we just have a matrix with two players, but I mean it is easy. It is easy to build a matrix, a 2D matrix with two players. But what happens when we have three players? For example, like in this example here. In this case, I have different players, as you see here. And player one is playing A. Player one can play A or B, and then player two can play C or D, and then player three can play E or F. Okay, but player three, okay, and then how we represent this game in the strategic form? This is the question. So, well, let's analyze a little bit more the game and then see how to translate this to the strategic form. So, the strategy set of player one is just A and B. Okay, is the only thing that player one plays. Starts the game, plays A or B, and that's it. Player two can play C or D, but player two doesn't know the previous movement of player one. Okay, and then player three can play. Player three can play from different places here. I mean, if player one play A and player two played C, then at this point player three can play E or F. Okay, well, this is an information set for player three, so he doesn't know what player two played. Okay, and also doesn't know what player one played. Okay, but if we are at this point of the game tree, player three can play A, E or F. Okay, E or F. So in the first decision, in the first information set, player three can play E or F. Okay, then we have another information set here that it is when player one plays B, player two plays C or D, we don't know. At this moment, player three can play A prime or F prime. Okay, in this information set, player three can play E prime or F prime. So in the second information set, this one can play F prime or E prime, sorry, or F prime. Okay, so player three, strategies of player three have two components. The first component for the first information set and the second component for the second information set. While player one and player two can only play the strategies of player one and player two only have one component, which is just one action, playing A or B in the case of player one and C and D in the case of player two. So, and now to draw the strategic form of this, we just define, we fix the strategy of player three, and then depict the matrix for player one and player two. This is the, and then create a matrix for the strategies of player one and player two, and then here we have the utility. Well, in game theory we call it payoff, and then we have the payoff for each of the players. So this is a way of representing like a three-dimensional matrix. It is difficult to visualize. Then the idea is to fix strategies of one player and then draw the matrix for the other players. This is the the way in which we typically represent these strategic forms when we have three players. For more than 3 players, this becomes really cumbersome and difficult to analyze. So typically we don't go for strategic representations with more than 3 players. Okay, well, to finish, yeah, essentially, yeah, we are, I mean, these are the possible strategies of each player, the strategy sets of each player. A player can play A, B, player 2 can play C, D, and player 3 can play these 4 strategies. And here we are fixing the strategy, the different strategies of player 3, and then we are drawing the matrix with the rest of the strategies of player 2 and player 1 and player 2, and then putting the payoff here inside this matrix. Okay, so this finalizes the basic introduction to game theory concepts, and then we are going to see a scenario in which we have strategic interactions in blockchain. And this is the scenario of a remote purchase. And consider, for example, this example, the previous example, sorry. Yeah, we have a seller and a buyer, and the buyer wants to buy some good, but the problem is that the seller, the buyer and the seller, they are remote. They are exchanging information in a remote way, so they are not in person. And well, here is how we manage this situation in a blockchain. Well, I mean, here, if the buyer and the seller doesn't share, I mean, if the buyer and the seller doesn't have any previous relationship, then we need to assume here some trust. Typically, the entity that is considered trusted is the seller. And why? Because the buyer is the one who typically puts the money. I mean, first, buyers are not trusted in general. So the seller needs to receive the money before sending the good to the buyer. And this is how we typically solve this problem of a remote purchase, by essentially trusting the seller. But what if the seller is not trusted? Or what if we cannot trust the seller? Because, I don't know, the seller is in a foreign country, I don't trust it, so what do? Typically we put intermediate third parties. This is one way of fixing this problem. So in this case, the buyer deposits money on the third party, and the third party, and we need to wait until we receive the good. And after that is when the third party pays the seller. Okay, so if the buyer and the seller cannot trust each other, many times we introduce a third party to fix this problem. Well, can we do this in another way? And yes, we can do it. We can do it with blockchain, in fact, and with a smart contract. So the idea is to replace the third party, in this case, by a smart contract. And then there is this strategic interaction, because the buyer and the seller, both, they are going to interact with the smart contract. And well, let's see how to build a smart contract for this remote purchase. And what is going to be the idea? The idea is of the smart contract, and we're going to see the code in a moment, and we're going to test it. The idea is that the buyer can will deposit the amount of money for the purchase on the smart contract. Well, we're going to do several iterations on this. Let's build a very simple application in this simple smart contract, or in this simple application, the buyer deposits money on the smart contract. The buyer deposits this money, and then you cannot. I mean, you will not able to recover this money anymore. So the money is in the smart contract, and we need to wait for the good, for the delivery of the good. So the seller needs to deliver the good to the buyer. Until this situation doesn't happen, the money is on the smart contract. Okay, this is also called an escrow smart contract, because is in custody of this money until we receive the good. When we receive the good, we send a transaction to the smart contract, and the smart contract pays the seller. Okay, so and this is a way of fixing this problem. And let's see the code of this. So let's see this code, and here you have it. So this is a smart contract, and yeah, the idea is that the seller deploys the smart contract, okay, and then the buyer deposits the amount of money of the good that he wants to receive. In this case, we are putting here an ether, okay, and then we wait until the sender must wait until it receives the good. Let's see again the picture here, and let's see all the different functions that we can call. So this is a basic sketch of a purchase with blockchain, and the idea is that the buyer creates we have the buyer and the seller. The seller creates the smart contract, okay, with the code. In this case, it is selling, for example, let's say TVs, and then the buyer needs to send a transaction to the smart contract, depositing, let's say, 1 ether, okay, in the smart contract. And then the seller will see that there is an ether in the smart contract that and send the good, the product in this case, which is a TV, to the buyer. And then the buyer can only do one thing: call the function confirm delivery. But the buyer is not going to call this function until he receives the good. Okay. But when he receives the good, he calls the function confirm delivery, and after that, when the buyer calls this function, then the smart contract pays the seller. Okay, this is the simple idea of this smart contract. And let's go back to the code now again to see it. Okay, so this is a simple remote purchase smart contract. We're going to store here the address of the seller and the buyer. When we deploy the smart contract, the seller is set to the address deploying this smart contract. And yeah, these two functions are only can only be called by the buyer. And when to buy, in this case, this TV, what the buyer needs to do is to send a transaction to this deposit payment function, and send 1 ether to this function. If this happens, then we record here that the address that the buyer is the sender of the transaction to this function, and that the ether that is deposited here it comes from this address, and then essentially the seller will see that there is an ether in the smart contract, and after that will send the product, and finally the buyer will call this function when he receives the product, and if it is happy, he will call this function here, confirm delivery, and this function what does is send the ether to the seller. Okay, so let's test it. Let's go here. Let's deploy this smart contract. The smart contract is deployed. Okay. Let's check. We don't have any. We don't have buyer yet. We have a seller. The seller is the account that deployed the smart contract. In this case, 5B3. And now someone wants to buy one of our products, a TV in this case. To do so, you need to send an ether. Okay. So I'm going to do a deposit payment from another account. Let's say that the buyer is AB8. And we're going to send 1 ether to buy this TV. So I call deposit payment. It's okay. Now we have the buyer is this account here. Okay. The smart contract has 1 ether, and the smart contract has 1 ether, but this ether can only go to the seller. Okay. But we need to send a transaction from the buyer. The buyer must be happy, must receive the product in good conditions and so on. And if so, he will call this function here. Okay. Observe that the buyer cannot recover the ether. I mean, so the only thing that can do is confirm the delivery or wait, because until if there is something, if there is some problem, obviously I will not confirm the delivery. Okay. But if I receive the product and I'm happy, I just confirm the delivery. Let me see if I have AB8 is the seller. Okay, so I confirm the delivery, and that's all. And now, yeah, the seller has 1 more ether, and but we achieved the remote purchase. This is one example, and here we have an interaction with the smart contract. Maybe you could think that well, this is the smart contract. In the slides, you have a variation of this with like a programming another way, like a state machine. You can take a look. That is not that important. The thing is, okay, maybe we can have problems here with this strategic interaction. Maybe, I mean, in the actions that these two parties are going to fulfill. For example, what if after the buyer deposits 1 ether on the smart contract, then the seller doesn't send the good. Okay. What happens here? Well, what happens is that the buyer is losing 1 ether, okay, because the buyer deposits 1 ether on the smart contract, but then the seller is not sending the good. So we have a problem here. Well, and the problem is mainly for the buyer. Okay. Well, the seller is maybe also losing something. Maybe he's losing reputation in some way, or well, he's not providing a good service. So maybe if other people see this situation, then the seller will not sell more TVs. Okay, so this is one possible problem. Another problem is, okay, this is I do the deposit and then nothing else happens. Well, this is a problem, mainly for the buyer. The other possibility is that the buyer deposits, the seller sends the product, okay, but the buyer doesn't call this function, confirm delivery. So here the problem is that the seller the problem is that the seller here is not receiving the money, but it has sent the product. Yeah, apologizes because I think this is the seller. This is the seller, sorry. The seller loses, sorry. This is the seller. And what if the buyer doesn't send the last transaction? Then the buyer, I mean, what happens if the buyer doesn't send this last transaction? Then we will have a problem here, because the seller is not going to get his ether. So the problem here is that maybe the participants are not losing any economic value here, because if they do something wrong here, they don't lose money, essentially. So the idea is, can we transform this strategic interaction in such a way that you lose money if you don't follow the correct path, let's say? And the idea is that, yes, we can improve this design a little bit now in the following form. Now the seller has, when the seller creates the smart contract, it needs to deposit also an amount of ether. Let's say, for example, that the product that we are going to buy has a value of 1 ether. Then the seller is going to put also 1 ether on the smart contract, and the buyer is going to put 2 ethers on the smart contract, the double. Okay. So now the smart contract has 3 ethers in it. Okay. And so if the execution doesn't finish, it's not finished, but at this moment, the buyer is losing 2 ethers, and the seller is losing 1 ether. Okay, so both parties here have the incentive to finish correctly this execution. So when the seller sends the TV, then the buyer finally has an incentive to call this function confirm delivery, because the confirm delivery will give 1 ether back to the buyer, and then will give 2 ethers to the seller. Okay. If we don't finish, then we are both losing money. Okay, and in this case we are using the smart contract as an escrow for this purpose. So, well, maybe it's not perfect still, because, you know, after execution of this transaction, if the protocol stops here, well, the buyer is losing twice. Okay, I mean, they are not losing the same at different stages of this remote purchase protocol. Parties are losing different amounts of money. In this case, if the protocol stops here, well, the buyer is going to lose 2 ethers, and the seller is going to lose 1 ether. Okay, so yeah, buyer is losing more. But if the seller sends the product, and after step 3, well, it is the other way around. I mean, the seller is losing more money because it sent the TV and the ether. So it is like losing 2 ethers and the buyer is losing 1 ether only. Okay. So if you want to to make the protocol, well, this is a variation of the protocol in which everybody is losing a similar amount of money. In this case, we could do this. I don't know. It is not practical because I don't know how many people has like 100 ethers. But if you increase this value regarding the product, then both are losing a similar amount now. Okay, because we are sending to the smart contract an amount that is much bigger than the product that we are buying. Okay, so and another problem that we can fix here is that what if the buyer doesn't hurry in call this function confirm delivery? Okay, well, we can force this also. For example, putting in the smart contract, we can program here something that says that, okay, if you don't finish all the execution, then you are exposing yourself that someone can send a transaction and burn this ether that is in the smart contract. So, for example, we can also force the completion of the protocol with strategies like this. Okay. Well, you can imagine many different things here. So, well, this was an example in which there are two parties and there is a strategic interaction between them. It is obvious that intermediaries will not disappear with blockchain, but they will transform their role in the form of smart contracts. Finally, just mention about layer 2s and based on this approach, you may wonder what happens if I want to purchase something that the value is really low. I mean, maybe the fees of sending a transaction to the blockchain are superior than the value that I'm trying to purchase. Well, but for this situation, you can use some strategy to create a micropayment architecture. For example, in this case, suppose that I want to buy, I'm going to buy multiple t-shirts from a seller. Okay, I'm a buyer. What I can do is to deposit a certain amount of ether here, 10 ethers, for example, and then we start have some interaction with the seller. I mean, I buy different products from this seller, and each time the seller gives me one of these products, I send a signed transaction, and I am increasing the amount of money each time the seller is providing me products. Then I create signed transactions with a higher value. Okay, but these transactions are not sent to the blockchain. Okay, they are just they are like, this is called a payment channel, but they are kept by the seller, and when we finish our relationship, then the seller just sends the last transaction with the highest amount and paying only one fee. Okay. And this is the idea of a layer 1 and layer 2, because we are not, as in this example, as you see, we are not writing all the transactions in the blockchain. We will just write the last transaction that I have from the buyer. Okay, so yeah, this is something that there is some complaint about current blockchain systems because they don't have high rates of transactions per second. But with these layer 2s, in which we are exchanging a lot of information off blockchain, we can effectively increase the number of transactions per second, in fact, that the system is doing. Okay. Okay. So this is the summary of what we have been seeing. Well, we present the scenario of a remote purchase. We finalize a little bit some concepts of game theory, and then we start analyzing this scenario of the remote purchase. We analyze it with a third party, and then we put a blockchain here and a smart contract, and we show the smart contracts that can be used to build this to this application. We saw the concept of escrows, in which you need to deposit money here, and you lose money if you don't currently complete the purchase protocol. And yeah, and finally we saw a little bit the concept of a layer 2 or a payment channel.